My name is Leif and I'm a salesman. But it's really good that we have some more AMD people in the room here. Would I show me some hands there? Josh, Bill. Ex-AMD people. Also Mr. Torricelli. So in case you have any questions, so feel free to contact us during the show. Today I will be presenting a little bit about our future strategy, a little bit about our current product as well. Just to give you sort of a short view where we stand today with our portfolio. So today we have a portfolio consisting of both GPUs and CPUs. So as you heard from Dell, these products sit in a numerous different kinds of boxes today, which you can buy from different vendors. What we are working on is what I will be explaining today to do with these products in the future. Since they do share the common goal of providing the heterogeneous computing environment for the future. That's where we want to be heading. On the CPU side, we do have a roadmap sharing that we will continue to build on the AMD architecture, but with a new core design. So the new x86 core design is something that will soon be launching. And that will be the basis then of the products providing the heterogeneous computing from the CPU standpoint. This new core design has been focusing a lot on power consumption because that's what the customer has been asking for. The largest customers we do have, I mean even outside of HPC, is very focused on power consumption today. It's the main focus when we talk to them. So that's why we did a lot of changes to design to improve power consumption. There's also numerous other design changes, of course. One important thing is the new core design. The new core design has a completely new floating point unit and a completely new integer computational unit as well. So any in-depth information you would like to have on this, you're welcome to contact us during the show. We can do NDA presentations. We can also answer your questions in the bar. So we are very flexible at AMD. As we are flexible, this CPU then has something called a Flex FP design. The Flex FP design, that means that the new floating point unit can both execute 128-bit mode and 256-bit mode. So we can both be running the Intel compatible code and the code which is going to be more optimized for our architecture then. When it comes to optimizing for our architecture, we are working with a number of software vendors right now, and also our own compiler, the Open64 compiler, with the focus of having everything ready at launch then. And thanks to all the engineers who put in a lot of work to this, Josh. So as I said, launching soon, very promising. I actually already have numerous customers asking a lot of questions about this, so yeah. When it comes to GPU then, a lot of the work that we're doing there right now is based on software actually. As I mentioned, software is really needed for the new products that's coming, and it's not actually not only the GPU that is a product that we have right now, it's something called an APU also. So we just had the developer conference in the US ending in a couple of days ago, where we presented a lot about our future software stack then. And a lot of that software stack is going to be used for the future HPC strategy as well. But we're starting on the consumer, on the client side. That's where the really large volumes are, to attract sort of the newer programming paradigms, to use the GPU and CPU that we have inside the APU. The APU is then, that's a combination of a CPU and a GPU. Accelerated processing unit. The current GPU products that we do sell for HPC, we have two products, the 9370, which is a double slot, and the 9350, which is a single slot product. What we did disclose during the Fusion Developer Conference I just mentioned over in the US a couple of days ago is a new graphics core design. So that information I'm sure will be available on the web in a couple of days. So it's a completely new core design on the GPU as well, not only on the CPU. But it is so new that I don't even have the slides myself, so yeah, sorry for that. But the whole reason of doing this is then to provide an architecture that goes outside of the x86 and what we can do with 86, and use the acceleration of GPUs and CPUs and APUs working together. A lot of this work has, of course, to be done on the software side. So as I said, a lot of the work where we currently are focusing is on the software side as well, not only on new core designs. So what we want to do also in the end is, of course, to provide some kind of a server APU, something you can put inside the server. But that's still, I mean, a couple of years away. So, I mean, that's nothing we can share with you today. But it will come eventually. So eventually we'll want to have a complete stack then of an integrated architecture with a common memory subsystem, which you can, as a programmer, easy to program for this environment, much easier than it is today to use accelerated computing. So in the end, everything will work together in a sweet harmony. Now I'm really sounding like a salesman. I hate this. But if you look at it from a more technical point of view, then I mean the whole reason is to provide a CPU with some of course GPU components as well, and still there's room for a discrete accelerator as well, providing the really high accelerations with a bolt-on memory on the discrete part, and in the integrated part we do have the shared memory architecture. So it's really a matter of them to figure out what way your code should be executing on this. And it's actually not only up to the programmer to decide that. We're going to provide a lot of tools to make it easy to make the code execute in the best possible way in this architecture, as shown on the previous slide. So the current software stack, we do have a software stack today as well. Actually, this is probably even changed this line since the Fusion Developer Conference the last couple of days. So there are so many new things coming in this arena. One of the vendors that we are working with in this area is also Microsoft, which launched the Microsoft C++ AMP as well, just to name one of the vendors that we do work with on the software side. It's not only us, it's an ecosystem. So what we'll be working on in the future and put a lot of focus into is to improve then the automation of things, so that the programmer doesn't have to figure out the optimal way to write the code to execute an architecture. Because the problem is, if the programmer decides the optimal way, he will of course write a very good code, but then next year we will come with that completely new hardware and he'll have to rewrite the code. And that, not all programmers like that. Some like it, some doesn't like it, some don't like it. So that will be putting a lot of focus on then on providing a hardware abstraction layer so that the programmer can work on a higher abstraction layer and still have good performance. I mentioned already the Fusion Developer Conference that we had. Everybody of you who find this slightly interesting that I'm talking about, I recommend to go in to the developer.amd.com address and watch a couple of the replays that are of the keynotes that went on this conference. Much more interesting than my talk today, I must say. So by that I will be ending my talk, and as I said, we are here for the show. So let's meet in the booth, in the bar, possibly at an NDA room as well. So have fun, guys. See you.